Hello, and welcome to another demo of a tool listed on the Exoplanet Modeling and Analysis Center. Today, I will show you how to use the ATMO generic grid. EMAC shares two grid tools created by the ATMO model, one specific to hot exoplanets and one that is applicable to a wider variety of planets, which we will look at today. This generic grid is capable of computing planetary transmission spectra for planets with hydrogen or helium-dominated atmospheres, with local or global condensation, and given values of temperature, gravity, and radius. The ATMO Generic Grid web tool is hosted by the Exoplanet Characterization ToolKit and can be accessed by clicking the respective launch link on the EMAC website. Once I arrive at the ATMO Generic Grid web tool page, I first specify the temperature in Kelvin and gravity in meters per second squared of the planet. Next, I input the planetary radius and stellar radius, normalized to Jupiter and the Sun respectively. Lastly, there are 5 standard model parameters to specify. The first of these is the type of condensation, local or rainout. A brief description of what this means is provided. The next 4 parameters to be specified are chosen from a given list of possible values. The metallicity in solar units, the carbon-to-oxygen ratio, the wavelength-dependent scattering opacity, and the uniform scattering opacity with cutoff at all wavelengths. Once all model parameters have been specified, I can click Submit to generate the spectrum. Scrolling back down, I can see the resulting transmission spectrum plotted here. If the temperature or gravity values I specified earlier were outside of the range acceptable to the model, I can see here that the grid shows the next closest match. When I'm done, I can click Save File to save the .dat file spectrum. The ATMO generic grid is an excellent tool for producing the transmission spectrum of a variety of exoplanets. Thanks for watching.